Hello my dear students, I warmly welcome you to Sia's digital classes. In this video, we are going to see some more models and some more types of questions being asked in our topic time, speed and distance. So let us start. So first of all, our next concept is relative speed. In the previous video, we have seen the concept of average speed. Now the next concept is relative speed. So whenever you see the word relative speed or the words like same direction and opposite direction, what you have to do is you have to, whenever you see a word which says same direction, what you have to do is you have to subtract them. So whenever you see same direction, x minus y is applied, where x and y are speeds. X and y are speeds and x is greater than y. So whenever you see same direction, what you have to do, you have to subtract them. And whenever you see opposite direction, what you have to do is you have to add them. So let us see here. There are two bodies or two cars or two trains here. Here, both of them are going in a same direction. So both of them are going to the right. So both of them are going towards what? Right side. I can say that they are going in a same direction. Then what I have to do is I have to subtract their speeds. So here speed 1 is v1 and speed 2 is v2. So we have subtracted their speeds and find the relative speed. So relative speed is nothing but whenever we are going in the same direction, we have to subtract. Whenever we are going in the opposite direction, we have to add. So here both of these cars or trains are coming towards each other, or they are going in opposite direction. This car is going to the right and this one is coming to the left. So this is opposite direction. What we have to do is we have to add them. So here v1 plus v2 is done. So v1 plus v2 is relative speed. Okay. Now let us see. So if S1 is the speed, S1 is 20 and S2 is 30, and both of the trains or cars are going in same direction. So whenever I see the word same direction, what I have to do, I have to apply the relative speed. Relative speed of same direction is x minus y, where x is greater than y. So here the x value is 30 and y value is 20. So the relative speed is what? 10 kilometers per hour. In the next question, S1 is 43 and S2 is 37, but they are going in opposite direction. So then the relative speed will become what? Relative speed is x plus y. So x is 43, y is 37. 43 plus 37 gives me 8. So the relative speed is 80 kilometers per hour. So this way we have to find the relative speed. Now coming to the next concept, which is trains or bridges. So in this topic you have to know what is the distance being covered here. So when a train of length t is crossing a pole, so when a train of length t distance is crossing a pole, then the distance will be what? So let us see. So if a train is crossing a pole, then how much distance it should cover? To cross that particular pole, it should cover the distance of train itself. So here the distance will become what? Length of the train. Here the distance will be length of the train. Whenever a train is crossing a pole or flag post or a man, then the distance is nothing but length of the train. Then our next scenario is whenever a train is crossing a platform or a bridge. Whenever a train is crossing a platform or a bridge. So to cross this particular platform, what the train should do is, first of all, it should cover the distance of itself, and then it should cover the distance of bridge or platform. So here there are two entities. So it should first of all travel the distance of itself, and then it also should cover the distance of bridge or platform. Here the distance value is nothing but length of the train plus length of the platform or length of that bridge. And in the same way, when two trains are going, irrespective of their relative speed or in which direction they are going. So if they are going in same direction or if they are going in the opposite direction, when two trains are going, the distance is, first of all, if they are crossing each other, both of the trains are crossing each other, the distance traveled by them is, first of all, the train 1 and the train 2. The train 1 should cover the distance of itself, and then it should cover the distance of train 2 also. Here the distance will become what? Distance is length of train 1 plus length of train. So you should remember this. When a train is crossing a pole, distance is length of train. When a train is crossing a platform or a bridge, distance is length of train plus length of bridge. And whenever a train is crossing another train, the distance is length of train plus another train. So let us see. So our first question says, a train of length 100 meters takes 10 seconds to pass a signal post. So a train is taking how many seconds? 10 seconds to pass the signal post. What is the speed of train in kilometers per hour? So a train is passing. So here our first question is given as like this. A train is passing a flagpole or signal post. So if the train is passing this particular post, the distance is what? Distance is length of train. Distance is length of train. Here the length of train is given as 100 meters. This will become what? The value of distance. And the time here, time given is 10 seconds. By using this, can I find the speed? Yes, I can find the speed. Speed is nothing but distance upon time, which is 100 by 10. So 100 by 10 is 10. But our speed is coming in meters per second, because distance is given in meters and time is given in seconds. So our speed is 10 meters per second. But what I have to do, I have to convert it to kilometers per hour. So 10 meters per second should be converted to kilometers per hour. So meter is smaller value, kilometer is bigger value. What I have to do, I have to multiply it with 18 by 5. 5 ones are 5 twos, 18 twos are 36. So the speed is 36 kilometers per hour. The speed of the train is what? 36 kilometers per hour. Now coming to the next question, which says two trains of lengths 80 meters and 90 meters. So length of train 1 is 80 meters and length of train 2 is 90 meters, are moving in opposite direction. So here what did he said? He said that they are moving in opposite direction with speeds of 10 meters and 7 meters per second. So speed 1 is 10 meters per second, speed 2 is 7 meters per second, and they are going in what? They are going in opposite direction. So they are going in opposite direction. So I said that whenever I see the word opposite direction or same direction, what I have to do, I have to apply the concept of relative speed. So let us apply the concept of relative speed here. Relative speed when they are going in opposite direction is x plus y. So s1 plus s2. Then relative speed will become what? 10 plus 7, which is 17 meters per second, and they are crossing each other. So they are, two trains are moving and they are crossing each other. Find the time taken to cross each other. So train 1 is crossing train 2. So whenever two trains are crossing each other, I said that the distance will become what? Distance is length of train 1 plus length of train 2. So the length of train 1 is 80 and the length of train 2 is 90. So our distance is 170 meters. So I have found the value of distance. D is 170 and relative speed is 17 meters per second. So can I find the time taken? Yes, I can find the time. So time is nothing but distance upon speed, which is 170 meters by 17 meters per second. So 17 tens are 170, meter gets cancelled. So our time is 10 seconds. So the two trains will cross each other in how many seconds? 10 seconds. Okay. Now coming to the next question, which says a train of length 150 meters crosses a bridge of same length. So the length of train is 150 meters and the length of bridge is also 150 meters. So let us see. Length of train is 150 meters and length of bridge is what? It is also 150 meters. So it is crossing that particular bridge. So whenever a train crosses a bridge, the distance will become what? Distance is length of train plus length of bridge, which is 150 plus 150 is 300 meters. So the distance is 300 meters. Now the time taken to cover that distance is 20 seconds. Time is 20 seconds. Can I find the speed here? Yes. Speed is nothing but distance upon time, which is 15 meters per second. But our speed is asked in kilometers per hour. Let us convert this value in kilometers per hour. So 15 meters per second should be multiplied with what? 18 by 5, because I am going to a bigger value. So 5 ones are 5, 5 threes are 50. So 18 threes are 54. So our speed is 54 kilometers per hour. So the speed of that particular train is 54 kilometers per hour. Now coming to the next question, which says a train passes a pole in 6 seconds and 210 meters long platform in 16 seconds. Find the length of the train and speed of the train. We have to find the length of the train and also the speed of the train. So basically this question can be solved in two ways. The first way is a basic method and the second way is little basic understanding and a tricky approach. So first of all, let us solve this in a basic way. So a train is passing a pole in how many seconds? Time is 6 seconds. So time is 6 seconds. Now if a train is passing a pole, I said that the distance it will cover is the length of train itself. So the distance is length of train itself. Let us assume the length of train as x meters. Length of the train as x meters. So time is 6 seconds. By using our formula, which is d by t, can I find the speed? Yes, I can find the speed of the train. Speed of the train is nothing but distance upon time, which is x by 6. Here I have found the speed of the train. Now in the second point, it said that a train passes a pole in 6 seconds and 210 meters long platform. So the length of platform is what? 210 meters, and the length of the train is what? X meters. So the train is covering the or crossing the platform. If a train is crossing that particular platform, then the distance will become what? The length of the train plus length of platform. So distance is nothing but length of train plus length of platform. So the distance is 210 plus x. Now it is taking how much time? It is taking 16 seconds. By using this, can I find the speed of the train? Yes, I can also find the speed of the train. So speed of the train is nothing but 210 plus x divided by 16. So both of these values are speed of the train. Let us equate them. So x upon 6 is equals to 210 plus x by 16. 3 2s are 6 or 2 3s are 6. 2 3s are 6 and 2 8s are 16. Now 8x is equals to 210 multiplied by 3 plus 3x. From this I can say that 5x is nothing but 210, and the value of x is 210 by 5, which is 40. 5 4s are 20, then 5 2s are 10, 42. So the length of the train is what? 42 meters. Sorry, here it should be 210 multiplied by 3. So 42 into 3. 42 multiplied by 3, which is x value. The length of the train is 126 meters. So we have found the length of the train. Here the length of the train is what? 126 meters. So by using this, can I find the speed of the train? Yes, I can find the speed of the train. We know the speed of the train is x upon 6. So speed of the train is equals to x value is 126. 126 by 6 is 21 meters per second. Okay, so here we have found the length of the train and we have also found the speed of the train. This is a basic approach for solving this question. So this question can be solved using a little bit tricky approach. Let us solve with the help of little bit trick. So I'm erasing this particular ink on this slide. So let us see. So in our question it said that a train is crossing a pole. So the length of the train is x meters. It is crossing a pole in how many seconds? 6 seconds. It is crossing a pole in 6 seconds, and that particular same train is crossing a platform of length 210 meters in how many seconds? 16 seconds. In how many seconds? 16 seconds. The train has not been changed. Here in the first one and in the second one, the length of the train is same, but we are getting an additional time of how much? 10 seconds. We are taking 10 seconds more time. This 10 seconds more time is taken by replacing what? So first of all, I had a pole. In our first equation or first scenario, I had a pole. When I have removed that pole and kept a distance of 210 meters, so I am adding what? I am adding additional distance of 210 meters. So I am adding additional distance of 210 meters. So for covering that additional 210 meters, the train is taking how many seconds? 10 seconds. So understand this. Whenever I am adding additional 210 meters, the train is taking additional 10 seconds. So by using this, here the additional distance is 210 meters, and the additional time taken by the train is 6 seconds. By using this, I can find the speed of the train simply. So the speed of the train is nothing but distance upon speed, which is 210 upon 6. 210 upon 10, sorry, here the time is 10 seconds. Okay, additional time taken is 10. So 0 and 0 gets cancelled. So the speed of the train is 21 meters per second. So I can simply say that it is taking 210 meters to cover a distance. It is taking 10 seconds to cover a distance of 210 meters. Then the speed is what? 210 by 10, which is 21 meters per second. So I have known the speed of the train. Can I find the distance or the length of the train? Distance is nothing but speed upon speed multiplied by time. So 21 into the train takes how many seconds to cross a road? 6 seconds. So 21 multiplied by 6. So the distance or the length of the train is 126 meters. Okay. Now this is a tricky approach. So in this way we can solve questions of time, speed and distance. So these are all the questions being asked in our exam from the topic time and distance. If you want to practice more questions on this topic, you can go into this particular section, time and distance, and practice some more questions. Thank you very much for watching this video and have a great day.